Good evening everyone, good evening. I welcome you all again to the VJEE Enthuse. Hope all of you are doing great, having a good time. Well people, if I'm audible and visible to everyone, let me know in the chat box with the thumbs ups, yes. Let me know in the chat box with the thumbs ups if I'm audible and visible to every single guy right here. Yes. Hi Khushi, hi Mubashir, hi Kashyap, hi Var, hi Fida, good evening, good evening. Hello Muhammad Assalam, Walaikum Salam. Good evening guys, good evening. Welcome to the session, welcome to the session. Yes, hi Sana, how are you doing? Wonderful guys, great. Hello Songi, Walaikum Salam. Hi Ravindra, how are you doing? Welcome to the session guys, welcome to the session. No Ravindra, I'm not a dancer bro. In no way. Who told you that? Hi Divyanshu, welcome, welcome. Hi Tesla, Walaikum Salam. No Ravindra, no, nothing like that, nothing like that. Alright guys, so let's get started with something pretty interesting. As you all can see the heading, yes, most expected JEE questions from the chapters Thermodynamics, States of Matter and Redox Reactions. Yes, most expected questions, most expected JEE questions from the three chapters, from the three important chapters, that is Thermodynamics, States of Matter and Redox Reactions. Yes. Okay, so people, before starting the session, let me introduce myself. As you all must be knowing now, my name is Wassim Sir and I'm your chemistry master teacher right here. Yes. That's great, Kashyap. Good luck, do well, good luck. Now, Vida, this is not the mentee. I'm going to show you some special type of questions from these three chapters, which are the, you can say, most expected questions from JEE, yeah? Okay. All right. So, people, let me show you the schedule of the week first. Then I'll be starting the session. Let me show you the schedule of the week. Yes, we are done with the solid state on Monday, and on the same day we did the mole concept marathon as well. And people, today we are going to do the most expected JEE questions from the chapters Thermodynamics, States of Matter and Redox Reactions. And tomorrow it's going to be again the chemical kinetics part 2, right? Tomorrow it's going to be the second session of the chemical kinetics, right? And then we'll be talking again the most expected JEE questions from the chapters chemical equilibrium, ionic one and the mole concept. Yes, and on Saturday we'll be doing the chemical kinetics part 3. Good evening Vignesh, good evening, welcome to the session. Walaikum Salam Atifa. Okay. Hi travel expert, what's up? Yeah. Alright guys. So for the ones who have not liked the video yet, do like the video, share and subscribe the channel at the same time so that everyone gets benefited out of these sessions, yeah? Okay, so people, before starting the session, this is something which you all must be knowing. This is the marathon series which we have started, me, Shreyas Sir and Shimon Sir, right? In your physics, chemistry as well as mathematics, right? On Thursdays, you have the marathon series with Shimon Sir. Fridays, it's going to be with Shreyas Sir. And on Mondays, it's going to be with me. Yes? Yes, absolutely, right? Okay. So guys, let me give you the brief introduction about the Vedantu JEE Pro subscription, like what all benefits you guys are going to get if you'll enroll yourself in this Pro subscription. Let me tell you, you guys are going to get 5,000 plus hours of live online teaching in which you'll be getting the regular tests and assignments which contains more than 10,000 questions. We have got 20 plus teachers guys here with 5 plus years of experience who will be training you personally for the upcoming JEE 2021 as well as JEE 2022. Yes. And people, at the same time, you have got the option to learn either in English or in Hindi. It's completely your wish to select the language, get trained by the master teachers of Vedantu in your physics, chemistry as well as maths, right? And at the end, let me tell you, we are going to cover everything which includes your micro as well as crash course right here. Okay. For the ones who are going to appear in JEE in 2021, we have come up with 3 different plans as you all can see, and on every plan right here we have got 20% off. Yes. So people, 1 month, 3 month and 6 month plan after the 20% off, you guys are just getting it for 6K, 16.8K and 31.2K respectively. Yes. Okay, and all these plans are valid for the ones who are going to write your JEE in 2021. We are going to cover your whole syllabus guys through these plans. Okay, it's completely your wish to select the plan, get trained by the master teachers of Vedantu right here through this Vedantu actual platform, right? Okay. At the same time, for the ones who are going to write the JEE in 2022, we have come up with 4 different plans as you all can see right here. And these plans include the 1 month plan, 3 month, 6 month and 12 month. After the 20% off, you guys are just getting these plans for 4K, 10.8K, 19.2K and 33.6K respectively. And all these plans are valid for the ones who are going to write your JEE in 2022. Okay. And for the droppers, as you all can see, again we have got 3 plans for you, right? 1 month, 3 month and 6 month. After the 20% off, you guys are just getting it for 7.2K, 20.4K and 40.8K respectively. And all these plans are valid for the JEE droppers. Yes. So people, get enrolled in these plans, get the plan and get trained by us personally through the actual Vedantu platform. Yes. Okay. How to get enrolled in these how to get these plans? Let me tell you, there's a link in the description box of the video. I want you guys to click on that link. Use the coupon code as WBPRO. On using the coupon code of WBPRO, you guys are going to get 20% off on this right here. You guys are going to get 20% off on whatever plan you're selecting for yourself. Yes? Right? Okay. So people, let me talk about the most expected JEE questions from the chapter Thermodynamics first. Okay? Let's do some important questions from the chapter Thermodynamics. Most expected JEE questions from the chapter Thermodynamics. Let me know in the chat box if you guys are super duper excited for it. Yes. Let me know in the chat box if you guys are super duper excited for it or not. Let me know in the chat box. Let me know in the chat box. Yes. Wonderful, guys. Great. Yes, Ravindra, I'll be doing that. I will be doing that. Yes. Yes. Good evening, Maria. Good evening. Okay. So people, let's get started with the session in which we are going to cover some expected JEE questions from few chapters like Thermodynamics, States of Matter and Redox Reactions. Okay. Let's get to know all these questions. Okay. People, as you all can see, the first question which is on your screen. This is the first question which is on your screen. Let's try to kill this one right here from the chapter Thermodynamics. Okay. We are given with 5 moles of an ideal gas. Yes, the first thing which is given to me, that is number of moles of the ideal gas. We are given with 5 moles of the ideal gas at 100 Kelvin. So I have got 5 moles of ideal gas right now at 100 Kelvin, right? So the initial temperature of the gas right here is 100 Kelvin. And it's allowed to expand. It's allowed to undergo reversible compression till its temperature becomes 200 Kelvin. Okay. So people, I've got 5 moles of ideal gas initially present at 100 Kelvin. Now there is some reversible compression going on by means of which temperature of the gas reaches till 200 Kelvin. So 200 Kelvin is the final temperature of the gas. Yes. People, we are given with something as CV, molar heat capacity at constant volume for the gas is given to us. Yes. What are we supposed to calculate? We are supposed to calculate delta U and value of delta PV for this process. We are supposed to take the value of R as 8 right here. Okay. This is the first question which is on a screen, and let's try to solve this one right here. Okay. People, what all things we are supposed to calculate? First thing, I'm going to calculate the value of delta U, correct? So delta U for the ideal gas, as you all must be knowing, delta U is equal to NCV delta T, NCV T2 minus T1 for the ideal gas. Yes, for N moles of ideal gas, I must say, right? Let's see if all the parameters are given to us or not. Yes, delta U will be equal to N value is 5, CV value is given to me, I guess. Yes, it's 28. It's 28. Temperature, final temperature minus initial temperature. Final temperature is 200, initial temperature is 100, 200 minus 100 means simply 100. Yes. So people, we can solve this. We'll be getting the value of delta U right here. And people, in all the cases right here, the delta U value is 14 kilojoules. 14 kilojoules. So what does that mean? That means from here, you'll be getting the value as 14,000 joules, correct? Which will be your 14 kilojoules. So first thing, I got to know the value of delta U right here is 14 kilojoules. Number 1. Number 2, guys. Number 2, we are supposed to calculate the value of delta PV right here. We are supposed to calculate the value of delta PV. See, we are done with the first part of the question. Let's try to kill the second one as well. Okay? Understand? See, guys, we are supposed to calculate the value of delta PV, correct? We are supposed to calculate the value of delta PV, correct? Now, guys, delta PV, can I write instead of delta PV, I'll be writing simply delta of PV is equal to nRT. Yes, I can say that. Yeah. Can I write it simply like this? I'll take N out. I've got 5 moles of ideal gas, right? R is already constant. It's going to be NR delta T right here, which is simply going to be NR delta T means T2 minus T1. Yes, people, N value is given to me. What is that? N value is given to me as 5. Yes, and we are supposed to take the value of R as 8, and it's going to be final temperature minus initial temperature, final minus initial, which is going to be 100. So it's going to be simply 8540. So it's going to be 4,000 right here. Yes, so 8540, 40 multiplied by 100, that means 4,000. We got the value something like as 4,000, which is going to be, this is going to be in joules. Sorry. Sorry guys, this will be simply 4 kilojoules, yeah? So just see the options. We got the value of delta U as 14 kilojoules, and we got the value of delta PV as 4 kilojoules right here. Which option is satisfying it? I guess third option is satisfying it. Yes, the third option is satisfying it. So it's done and dusted, right? The first question is done and dusted right here. Correct? Let's move on to one more question, guys. Exactly, the third option is the correct, and this is the solution which I showed you just here. Yes, first we calculated delta U, and after that we calculated delta PV, which is NR T2 minus T1, yeah? And we got the answer as 4 kilojoules right here, okay? Let's move on to one more question, guys, which is on our screen. Have a look, guys. Very nice question it is. Have a look. In an isothermal expansion, we have got the isothermal expansion of 1 mole of ideal gas happening. Yes. So people, 1 mole of ideal gas is undergoing the isothermal expansion against vacuum. That means he's talking about free expansion. Yeah. So people, can I say he's talking about isothermal free expansion? Yeah. Can I say the question is saying that we are doing the isothermal free expansion of the ideal gas. Yes, this is something which we are doing right here in this question. What are we supposed to calculate? From 10 liters to 100 liters, the quantity of heat absorbed by the gas will be. What do you think will be the answer right here? See guys, first of all, it's a free expansion. In case of free expansion, as you all must be knowing, the value of W is 0. Yes. Expansion against 0 external pressure is what we call as free expansion, right? So W value is 0. At the same time, it's isothermal. If it is isothermal, then delta U value must be equal to 0. Why is that? Because delta U is equal to NCV delta T. If in case of isothermal process, I mean, when the ideal gas will be undergoing the isothermal process, delta T value will be taken as 0. So delta U for the ideal gas which undergoes isothermal process, that will be 0. So I got the W value 0. I got the delta U value 0. If W is 0, delta U is 0, I can use the first law of thermodynamics. Delta U is equal to Q plus W. People, delta U, we already know that's 0. W value, we have got to know that is 0. Can I say from here, Q value will come to be equal to 0? Yes. So which one is satisfying it? I'll say option D is satisfying it, so D must be the correct answer right here. Yeah, yes, exactly. Wonderful, guys. The question is dusted. Yeah, he was talking about we are doing the isothermal free expansion of ideal gas. Yes, people, if you remember, if you have watched the entire video lectures of the chapter thermodynamics which I taught right here on this channel, when I taught you the free expansion, I made you write one statement. What was that? That was the isothermal free expansion of an ideal gas is adiabatic as well, if you remember. Yeah, that was the case. Yes, if you could remember that statement, you would have solved the question in one single, I mean in 3 seconds. Yeah, less than 3 seconds you would have solved this question. Yeah, the question is done. Let's move on to one more. Yes guys, this is one more question which is on our screen, right? See, 2 moles of an ideal gas are expanded reversibly. Okay, reversible expansion is happening, and the expansion is isothermal at the same time. So we are talking about the reversible isothermal expansion of an ideal gas from 10 atm to 5 atm. So initial pressure of the gas is 10 atm, final pressure of the gas is 5 atm, temperature is given to us as 27 degrees centigrade. What will be the value of Q, W, delta U and delta H in calories? Assume ln2 is equal to 0.7, right? This is the question which we have. Can we do it? Absolutely, guys, we can do it. Understand properly what I'll say. First thing, if you remember, when an ideal gas undergoes isothermal process, what happens? Delta U will be equal to delta H. Both the values will be equal to 0 for the ideal gas undergoing isothermal process. Yes. Why is that? Because we know delta U is equal to NCV delta T and delta H is equal to NCP delta T. Delta T is 0. If delta T is 0, both these values will be 0, right? Yes. So I got to know one thing, delta U will be 0 as well as delta H will be 0, correct? So both the terms must be 0. So either this will be the correct option or this will be the correct option, yeah? Only among these two. Now people, what am I supposed to calculate? Let's calculate work at the same time, okay? See guys, I have got 2 moles of ideal gas, right? Which is undergoing what? Reversible isothermal process. Reversible isothermal process. So first thing, delta U value will be equal to 0. Right? Delta U value, if it is 0 for the ideal gas undergoing the isothermal process right here, isothermal reversible process right here, delta U, as we all know, that is Q plus W. So Q plus W for the process will be 0, or I can say Q will be simply equal to minus W, right? This is valid for the isothermal process, correct? Now guys, understand. Now guys, understand what I'll be doing. Understand what I'll be doing. People, I have told you one relation by means of which we calculate work done in reversible isothermal process, if you remember. Yes. What is that? That is minus nRT ln P1 divided by P2. Yeah. Minus nRT ln P1 divided by P2. This is going to be the work. This is going to be the formula for work in order to this is going to be the formula in order to calculate the work done in reversible isothermal process. Yes, people, we are given with the value of N, if you remember. Yes, number of moles, we are given with 2 moles of the ideal gas. The value of N is given to us, correct? People, the value of R, since we need the answers in calories, and as per calories, our value is 1.98 kilocalories per Kelvin per mole, or I'll directly take 2 right here. What is the temperature given to us? Temperature simply is how much? Temperature was 27 degrees centigrade. That means 300 Kelvin. Yes. And people, it's going to be ln of P1 by P2. P1 is the initial pressure of the gas. P2 is the final pressure of the gas. So 10 divided by 5, that means 2. And ln of 2 is given to me as per the equation. What is that? That is 0.7, correct? So I'll get something like this. Minus 2 2s are 4 3s are 1200. Minus 1200 multiplied by what? Multiplied by 0.7. It's going to be, this is 0. This is 0, 7 to 14, 7 1, 7, 8. So 840 minus 840 calories will be the value of W right here. W is going to be minus 840 calories. W is going to be minus 840 calories. And if W is equal to minus 840, then that means Q will be equal to plus 840. So first option must be the correct one right here. Yeah? Yes? Got it, got it, got it. Let me know in the chat box if you got it. Yes? Yes, guys. Very, very simple question that was. Exactly. Option A is going to be the correct one among all. Yeah? All right, let's move on to one more question, guys. Let's move on to one more question. Understand properly. 1 mole of a non-ideal gas. Yes, this is the term. 1 mole of a non-ideal gas undergoes a change of state from 2 atm, 3 liter, 100 Kelvin. Correct? So people, I have got 1 mole of non-ideal gas which is present at the initial state. Let's say that at initial state, when the ideal gas is present at the state number 1, its parameters are 2 atm, correct? Its pressure is 2 atm, its volume is 3 liters, and at the same time, its temperature is 100 Kelvin. These are the state parameters of the non-ideal gas when present at initial state, correct? Now, people, we are changing the state of this gas. We are changing the state of this gas. And how do we change the state of the gas? The state of the system is changed by changing the value of state parameters, if you remember. Yeah. Now, people, the final state parameters are 4 atm, 5 liters, and 250 Kelvin. So I'm writing the final parameters. It's going to be 4 atm, comma 5 liters, comma 250 Kelvin. Correct? What are we supposed to calculate? We are supposed to calculate change in the enthalpy. Change in enthalpy of the process in liter atm will be. Okay? Understand, guys, what I'm going to do. Understand what I'll be doing. People, when this non-ideal gas is changing its state, is its pressure changing from 2 to 4? Yes. Its volume is also changing from 3 to 5. Its temperature is also changing. Yes. People, if you remember, I have given you one direct result. Delta H is equal delta U plus delta of PV. Do you remember this? This was the general relation between delta H and delta U, right? Correct? I'm not going to use the relation delta is equal to delta U plus delta NGRT. That is valid for only ideal gas, but this is the real gas right here. Yes, I cannot use that equation. Correct? Now, guys, understand. It's simply going to be equal delta H is equal delta U plus delta of PV is going to be simply P2 V2 minus P1 V1. Correct? We are supposed to calculate the value of delta H, and we are given with the value of delta U, that is 30 liter ATM, yes, plus P2, V2. This is the value of P1, this is the value of V1, this is the value of T1, this is the value of P2, this is the value of V2, this is the value of T2 right here. So people, P2 multiplied by V2, P2 multiplied by V2, that means 5, 4, 20, minus P1 multiplied by V1, P1 multiplied by V1, 3 into 2 is 6, yes. So what do you think should be the answer? It should be 30 plus 14, it must be 44. 44 ATM liter must be the value of delta H right here for this question, yes. So I got the value of delta H right here as 44 ATM liter, right? Yes. Very, very simple question it was, guys. Very simple question, yeah. Let's move on to one more question. See, guys, this you'll be getting in the form of PDF in Telegram after the session, yeah. Okay. One more question, guys. One more nice question it is, right? An ideal gas undergoes a cyclic process. All right, it's a cyclic process. People, in cyclic process, change in the value of any state function is always taken to be 0, as we all must be knowing, yeah? For the cyclic process, change in the value of any state function, that's taken to be 0. Be it delta U, be it delta H, whatever, be it delta G, anything, change in the value of any state function is always taken to be 0 for the cyclic process. Since it's a cyclic process, A goes to B, B goes to C, then C goes to A, correct? And this is for between P versus V right here. What are we given in the question? What are we given with the question? Delta U, change in internal energy for the process BC. It's given to me. Q, heat exchanged in between system and surroundings in the process AB, that's given to me. WAB is given to me. Work done during the process AB, that's given to me. WCA, work done during the process CA, that's given to me. Heat absorbed by the system during the process CA, correct? What are we supposed to calculate? Heat exchanged, heat absorbed by the system, right? We are supposed to calculate heat absorbed by the system during the process CA. We are supposed to calculate QCA right here. This is something which we are supposed to calculate, right? Okay, how do we approach this sort of a question, guys? How do we approach this sort of a question? Understand properly what I'll say. If I talk about the process AB, okay, but before talking, okay, let's talk about the process AB first, correct? For the process AB, if I write delta U, change in the internal energy in the process AB, right? Isn't it going to be, as a first law of thermodynamics, Q plus W? So it's going to be QAB plus WAB, yes, correct? Now people, is the value of QAB given to me? Yes, it's given to me. Is the value of WAB given to me? WAB value Q, wait, just a second. QAB is given to me, yeah. Yes, absolutely, QAB is given to me. WAB is also given to me. So people, QAB value, that is 2 kilojoules per mole plus, right? WAB, it's given to me as -5, correct? It's going to be as -5. So what is the value which will be coming from here? It's going to be -3 right here. It's going to be -3 kilojoules right here. It's going to be -3 kilojoules right here. I got the value of delta UAB over here, right? I got the value of delta UAB right here. People, I got the value of delta UAB, I have the value of delta UBC. For the cyclic process, for the whole cyclic process, delta U net must be equal to 0. Correct? If delta U net must be equal to 0, that means delta U during the process AB plus delta U during the process BC plus delta U during the process CA, it must be equal to 0. Yes. What all things do we have? What all parameters do we have? Do we know the value of delta UAB? Yes, we know it. How much is it? It is -3. Right? Do we know the value of delta UBC? Yes, it's given to us as -5 kilojoules. It's given to us -5 kilojoules plus delta UCA. It will be equal to simply 0. So it's going to be -8. So you'll be getting delta U during the process CA is going to be 8 kilojoules right here. Yes, this is the value of delta U for the process CA over here. Correct? Right? What are we supposed to calculate? Heat absorbed by the system during the process CA. Okay, so people, delta UCA as per first law of thermodynamics, can I write it as Q of CA plus W of CA? Yes, delta U is equal to Q plus W, so I wrote it like this, yeah. So I got something like this. 8 is equal to QCA. That's what we are supposed to calculate. QCA we are supposed to calculate plus WCA. WCA simply is 3. WCA simply is 3 kilojoules. Yes. So QCA is going to be 8 minus 3. That means 5 kilojoules. QCA will be equal to simply 5 kilojoules per mole right here. Absolutely. People, is the value of Q coming out to be positive or negative? Q value is coming out to be positive. That means heat is being absorbed by the system during the process CA right here. So what should be my correct option among all? Correct option among all should be option B right here. 5 kilojoules per mole. Yeah. Yes, very simple question it was, right? Let me move on to one more, guys. Yes, this is the solution of it as well. This you'll be getting in the form of PDF in the Telegram, right? Let me move on to one more question then. Let me move on to one more question again. Let's get to know how this question is to be solved. When 500 calories heat is given to the gas X, fine. In an isobaric process, okay, its work done comes out to be this much. That's great. The gas X will be, okay, a nice typical question this is. Nice and typical question this is, okay. Understand, guys, since it's the isobaric process, can I say Q will be simply equal to NCP delta T? Yes, Q will be equal to NCP delta T, correct? And people, since it's the isobaric process, can I write the W as W is equal to NR delta T right here? I can use this formula for this isobaric process. People, can I eliminate delta T from here? Yes, delta T you can eliminate as W divided by NR. Correct? Can you put the value of delta T over here? Yes. So Q value, you'll be getting something like this, NCP delta T. Delta T is simply W divided by NR. Can I say N and N got cancelled? So you got to know Q is equal to CP multiplied by W divided by R. What are we supposed to calculate? We are supposed to calculate what? The gas X will be. Let's get to know the value of CP from here. Can I say CP value right here will be Q multiplied by R divided by what? Divided by W. Yes. People, Q multiplied by R divided by W. Q is given to us as 500 calories, right? R value I'll be taking as 2 calories per Kelvin per mole divided by W is given to me as 142.8. Yes. Okay. So from here you'll be getting the value of CP. It's going to be 1000 divided by 142.8. Correct? 1000 divided by 142.8. People, what will be the value of CP around? What will be the value of CP around? Correct? Let's get to know its exact answer. 1000 divided by 142.8. 1000 divided by 142.8. 1000 divided by 142.8, that comes out to be 7. So CP value is coming to be 7. If the CP value is coming out to be 7, what does that mean? That means the gas is diatomic. Yes. If the gas is diatomic, then option A must be the answer. Yeah. Right? Yes, Jiva, absolutely. Yes. Albert, bro, I'm really sorry. I'm not getting time to check my Telegram, bro. I'm really sorry. Okay. I hope you get it. Yeah? Yes, tonight, I'll try to do it tonight, yeah. I'll try to see it tonight, yeah? Alright, let's move on to one more, guys. Molar entropy and temperature. Guys, is this the question? Let me know in the chat box which must be the correct answer, yeah? Let me know in the chat box fast. Let me know in the chat box fast. Molar entropy and temperature. Are these extensive, intensive, what? What do you think? Tell me, guys. Entropy of 1 mole of substance and temperature. Are these extensive, intensive, what? Both the ones are intensive properties. We have talked about these in detail if you remember, yeah? Let's do this sort of a question, guys. Okay, this is one nice question and a bit lengthy at the same time, yeah? This is one nice question but lengthy at the same time, yeah? Calculate the work done by the system, okay? We are supposed to calculate work done by the system in a single stage. Single stage. What does that mean? That means the process is irreversible, yes? That means the process is irreversible. Single stage adiabatic expansion of 2 moles of ideal gas. N value is given to me as 2. Correct? Gamma for the gas is 4/3 from 10 atm to 1 liter. From 10 atm to 1 atm. Initial pressure P1, final pressure P2. Correct? People, if you remember, I have told you in detail whatever is going to be the final pressure of the gas, that is to be taken as the external pressure as well. Yes, so final pressure is to be taken as external pressure right here as well at 300 Kelvin, right? Temperature is given to us as 300 Kelvin. Choose the correct option. What are we supposed to calculate? We are supposed to calculate work done in this irreversible adiabatic expansion. Yes, work done in this irreversible adiabatic expansion, correct? Now guys, work done in irreversible adiabatic expansion will be equal to simply minus P external delta V, that means V2 minus V1, correct? Right? Yes, work done in a single stage expansion, work done in irreversible process, it's going to be minus P external V2 minus V1. Now guys, understand, can I write it something like this? Can I write work done in irreversible adiabatic process is going to be minus P external. Instead of V2, can I write it like this? nRT2 divided by P2 minus nRT1 divided by P1, correct? Right? Absolutely. If I take nR as common, I'll be getting something like this. Work done in irreversible process, irreversible adiabatic process is going to be minus P external nR multiplied by T2 divided by P2 minus T1 divided by P1, correct? Now guys, what all parameters are given to us and what are we supposed to calculate? Since we need to calculate the work done in irreversible process, it's going to be minus P external. As I told you, whatever is going to be the final pressure of gas, you have to take that as the P external, which we have discussed in the actual sessions as well, right? Shahid, whenever single stage expansion is also called as irreversible, yeah? Irreversible is also called as single stage expansion. Single stage expansion या compression हो, वो irreversibly होता है, right? Right? Okay. Now guys, understand. Minus P external. What is the value of P external right here? P external, I told you that is 1 atm, correct? How many moles of ideal gas do we have? We have got 2 moles of ideal gas, correct? Okay, R I'm keeping as such. R I'm keeping as such. T2 is the final temperature, which I do not know. I'll calculate that in a while. P2 is the final pressure, which is 1 atm, correct? Minus T1 divided by P1. T1 is the initial temperature, P1 is the initial. So 300 divided by P1, 300 divided by 10, that means 30. Yes, that means 30. I'm removing this one from here as well. So people, I need to calculate the value of W irreversible right here. And in order to calculate the value of W irreversible, I should know the value of T2. Now the point is, how do we calculate final temperature in irreversible process? In irreversible adiabatic process. Do you remember that, guys? I've told you one general procedure to do that, if you remember. It's going to be simply equal to, as per, if I write the first law of thermodynamics for the adiabatic process, it's going to be delta U is equal to W. Yes. And delta U, as you all must be knowing, it's NCV T2 minus T1 is equal to minus P external V2 minus V1. Yes, I can write that. Okay. Now CV, guys, as you know, CV is R divided by gamma minus 1. Yes, R by gamma minus 1. It's going to be T2 minus T1 is equal to minus P external, minus P external. Instead of V2, can I write NR T2 divided by P2 minus NR T1 divided by P1 right here. Yes. Can I say this NR got cancelled. So I got the final equation as T2 minus T1 divided by gamma minus 1 is equal to minus P external. It's going to be simply T2 divided by P2 minus T1 divided by P1. Correct? Yes. Now guys, have a look. T2 we are supposed to calculate. First of all, I'm supposed to calculate T2. Why? Because I want T2 in this equation. I want T2 in this equation, then only I can calculate the work done in this irreversible process, work done in the single stage process right here. Yes. Now guys, T2 I'll be calculating. So T2 minus T1 value. What is the initial temperature of the system which is given to me? That is 300. Yes. Divided by gamma minus 1. What is the value of gamma? Value of gamma is given to me as 4 by 3. So 4 by 3 minus 1 is going to be 1 by 3. 1 by 3, that means that 3 will come up right here. Will be equal to minus times P external. P external is given to me as 1. Correct? Now we will T2 divided by P2. T2 I'm writing as such, which we are supposed to calculate. Divided by P2 value. P2 value is 1 minus T1 divided by P1. T1 is simply how much? T1 is 300. P1 is 10. 300 divided by 10 is 30. Yes. So people, from this equation, can I get the value of T2 right here? Absolutely, I can get the value of T2. T2 is simply going to be equal to 930 divided by 4. 930 divided by 4 Kelvin, you got the value of T2, right? When you'll put the value of T2 right here in this equation, guys, what are you going to get? What are you going to get? Instead of this T2, what I'm writing its exact value. It is 930 divided by 4 over here. Yes. And people, when you solve this equation, you'll be getting the value of W as minus 405 R. Yes, this is the value of W which you are getting right here. Since we are supposed to calculate work done by the system, it's mentioned in the question itself, we are supposed to calculate the work done by the system. This negative sign, it indicates that work is done by the system. And in the question, it was asked that work done by the system. So I can say work done by the system will be simply equal to 405 R. So 405 R is going to be the correct answer of this one. Yes. Let me know in the chat box if it is clear to every single guy or not. Yes. Let me know in the chat box, guys, if it's clear to every single guy. Yes. I want everyone to do it fast. Just let me know, just let me know, just let me know. Wonderful. Yes, you can take the video a little back. You can get it, yeah? Right? Okay. Let's move on, guys. Let's move on. The correct option was option C, and you saw the solution as well. Okay. Which one of the following equations does not correctly represent? Which of the following equations does not correctly represent the first law of thermodynamics for the given process involving an ideal gas? Assume non-expansion work as 0. Okay, fine, great. Have a look, guys. In case of cyclic process, I need to select the incorrect option. Yeah, I need to select the incorrect option. For the cyclic process, we know delta U will be equal to 0. Why? Because for the cyclic process, change in the value of state function, that's always equal to 0, right? Delta U is 0. If delta U is 0, Q is equal to minus W. So first one is absolutely correct, right? In case of adiabatic process, delta U is equal to minus W. Is that clear? Is that correct? People, if I use the first law of thermodynamics, delta U is equal to Q plus W. For the adiabatic process, Q value is 0. That means delta U will be equal to W. But over here, it is giving that delta U is minus W. So people, this is incorrect. So I was supposed to check the incorrect one. So this is my incorrect one, yeah? Yes. This is absolutely correct. In case of isochoric process, delta V will be 0. If delta V is 0, that means W is 0. If W is 0, that means delta U is equal to Q. This is correct. Isothermal process, delta U is 0. So Q will be simply equal to minus W. So B is not correct at all. Yeah. Very simple it was. Correct. Let me move on to one more question, guys. Let me see if you can solve this one or not. Again, a very, very simple question. It is a process has delta H equal to 200 joules per mole. Delta S is equal to 40 joules per Kelvin per mole. Out of the values given below, choose the minimum temperature above which the process will be spontaneous. All right, I need to check the minimum temperature above which the process will be spontaneous, right? As you all must be knowing, for the process to be spontaneous, its delta G must be less than 0, right? For the process to be spontaneous, delta G value for the process must be less than 0, right? Now guys, how come delta G will be less than 0? Delta G is equal to delta H minus T delta S. This is basically delta G for the system at constant pressure and temperature. This must be less than 0. Okay, and delta G, as you all must be knowing, that is delta H minus T delta S. It should be less than 0, correct? So people, I can say delta H must be less than T delta S, correct? Or I can say T delta S should be greater than delta H. Yes, or I can say temperature should be greater than delta H divided by delta S. Then only the process will be spontaneous. What is the value of delta H? As you all can see, delta H is 200, delta S is 40. 200 divided by 40 is 5. So temperature must be greater than 5 Kelvin. Then only the process must be spontaneous. Yes, so option C must be the correct one among all. Yeah. Yes. Got it. Wonderful. Great. Let me move on to one more then. This is the answer of it, guys, as you all can see now. Okay. There is one more question which we have right here. Let's try to kill this one as well. A system expands from 5 liters to 10 liters. Okay, that's great. Initial volume of the system is 5 liter. Final volume of the system is 10 liter against a constant external pressure of 2 atm. We got P external value as 2 atm. This is P external. If it absorbs 800 joules of heat during the process, system is absorbing heat. That means Q value is equal to plus 800. Yes, choose the value of delta U. Okay, have a look. Simple, guys. I'll be using the first law of thermodynamics. As per first law of thermodynamics, delta U will be equal to Q plus W, right? Now, in order to calculate in order to calculate delta U, I should have the value of Q and I should have the value of W right here. Yes. Now, guys, system is absorbing 800 joules. If the system is absorbing 800 joules, Q value will be simply plus 800. Yes. Right? And people, I got the value of Q. I should know the value of W, then only I can calculate the delta U. Now, people, what is W? W is simply minus P external delta V. Delta V means final volume minus initial volume, right? Minus times P external is given to me as 2 atm. Yes, it's 2 atm. V2 minus V1. V2 is the final volume, V1 is the initial volume. 10 minus 5 is 5. So the value is coming as minus 10 atm liter right here. People, can I convert this into joules? Yes, minus 10 into 1 atm liter is 101.3 joules. Yes, so the W value will be coming as minus 1013 joules right here. Okay. I got the value of W, I have the value of Q. I can put these into this equation. I'll be getting the value of delta U as Q. Q value is 800 joules, right? Plus W value I got to know as minus 1013 joules. So I'll be getting the value of delta U right here as minus 217 joules. So option D is going to be the correct one among all. Yes? Correct? Correcto? Yes, guys, let me know in the chat box if it's clear to every single guy right here. Wonderful. Yes. Correct. Absolutely correct. Yeah. Okay. Let's move on to the one more chapter in which we'll be doing the expected JEE questions. Yes. Let's move on to something called as states of matter. Yeah. Sojit, bro, I didn't see that. I'm sorry. Yeah, that's great. That's great if you told me that earlier. Let's do some expected questions from the chapter states of matter as well. Till now, we are done with thermodynamics part. Let's enter into states of matter part. Yeah. Let's see how these questions of states of matter will be solved right here. Understand properly what I'll say. Okay. The first question, guys, which is on your screen, an open vessel. People, which concept I'll be using? Open vessel concept. And as per open vessel concept, pressure is kept as constant. Yes, we have discussed that in detail if you remember. Yes, open vessel concept, pressure is kept as constant. Yes, at 27 degrees centigrade, right? So the gas which is in the container, that is at 27 degrees centigrade, is heated until 3/8 of the air in it has been expelled. All right. Assume that the volume remains constant. Fine. Calculate the temperature at which the vessel was heated. Okay. How this question can be solved? Understand properly, guys, what I'll say. I've got one open vessel right here. This is one open vessel right here. And in this open vessel, what do we have? We have got a gas in the container. We have got the gas in the container, right? Now, guys, the temperature of the gas right here, which I'm representing by T1, is 27 degrees centigrade. That means 300 Kelvin. Let's say the number of moles present in this gas, which I'm representing by N1, that is equal to N, correctly? Yes. Now, guys, what I'm doing right here, I'm heating it up. When I'm heating the gas up, what is happening? Some of the gas is coming out of the container. Yes. Now, how much gas is getting expelled from the container? 3/8 of the gas in the container is being expelled. If total moles of the gas in the container were N, so 3/8 into N will be getting expelled out. So once the gas gets expelled out, how much gas will be left in the container? I'll say the final moles of the gas in the container will be initial moles minus 3/8 of N has got expelled out. So it's going to be 5 divided by 3N. Yes. So these are the moles of the gas present in this container right now after 3/8 of the air is expelled out. After the 3/8 of the gas is expelled out. Yes, right? What are we supposed to calculate? We are supposed to calculate the final temperature T2. Okay. Now, guys, since we are using the open vessel, so we are going to use the open vessel concept in which pressure of the gas is kept constant, and it's mentioned in the question that volume is also remaining constant. So volume is also remaining constant. People, if you remember one equation from the ideal gas, yes, what was that? That was the master equation. P1 V1 divided by P2 V2 is equal to N1 T1 divided by N2 T2. Correct? Now we got to know this is open vessel concept, so pressure is constant, volume is constant. So whatever pressure and volume terms do we have, just cancel all them. Okay, so I get the equation in the form of N1 T1 is equal to N2 T2. I know the value of N1, that is equal to N, right? I know the value of T1. T1 value is simply 300 Kelvin, right? T1 value is simply 300 Kelvin it is going to be simply equal to N2. N2 is 3, 8, right? N2 is 5 by, just a second guys, it's not 5 by 3. It is 8 minus 3, 5 divided by 8, yeah? N2 value is 5 divided by 8 multiplied by N multiplied by T2, correct? Can I say N and N will get cancelled out? So T2 will be 8 3s are 24, 2400 divided by 5. It's going to be 5 4s are 20, 5 8s are 40, it's going to be 480 Kelvin. So 480 Kelvin is going to be the final answer of this question, right? But do we have the temperatures in Kelvins or degrees centigrades? The temperatures are in degrees centigrade. Just convert this temperature in Kelvin, right? Just convert this temperature in degrees centigrade right here. Yes. Just convert it. You know what's the relation? Yes, temperature in Kelvin is always equal temperature in degree centigrade plus 273.15, correct? So I can say temperature in Kelvin, I got to know as 480. 480 minus 273 will be equal temperature in degree centigrade. What is this value all about, guys? This value will be, I guess 300, it's going to be 207, I guess, yeah? So 207 degrees centigrade is going to be the correct answer of this question, yeah? Right? Yes. Let's move on to one more question, guys. Let's move on to one more question. 50 ml each gas A and B takes 150 and 200 seconds respectively to effuse through a pinhole under similar conditions. If the molar mass of B is 36 grams per mole, what will be the molar mass of A, right? People, this is the simple concept. This is the simple question based on Graham's law of diffusion, if you remember. As we all know, as per Graham's law of diffusion, rate of effusion is inversely proportional to square root of molar mass. Yes. More the molar mass of the gas, less the rate. Less the molar mass of the gas, more the rate of effusion. Yeah. Now guys, 50 ml of each gas A and B. I'm given with gas A, gas B. Now 50 ml of gas A is getting effused and 50 ml of gas B is also getting effused. 50 ml of gas A is getting effused in 150 seconds and the same 50 ml of gas B is getting effused in 200 seconds. Yes. Right? Molar mass of B. Molar mass of B is given to us as 36 grams per mole, right? We are supposed to calculate the molar mass of A. Correct? Correct? How do we do it? How do we do it? How do we do it? See guys, understand properly what I'll be doing. First of all, 50 ml of gas A is effusing. Over here, again 50 ml of gas B is effusing. 50 ml of gas A takes 150 seconds to effuse. 50 ml of gas B takes 200 seconds to effuse, yeah? So can I say this gas is effusing faster, right? Because it's taking lesser time to effuse, yeah? This gas is effusing faster, right? So rate of effusion of gas A is greater than rate of effusion of gas B. Since rates are inversely proportional to molar masses, more the rate of effusion, less the molar mass. So I can say molar mass of gas A must be less than molar mass of gas B. What is the molar mass of gas B? Molar mass of gas B is 36. So molar mass of gas A must be less than 36, yeah? There is only one option which is less than 36. Which one is that? Option A. So done and dusted, yeah? Let me know in the chat box if it's clear to everyone. Let me know fast, let me know fast, let me know fast. Anil, that's not bro dancing, that was modeling, that is ramp walk, जो देखा होगा Instagram पे. Thank you Aditya, thank you. Okay. Let's move on. Okay. This is one more question which we have on a screen. Have a look, guys. Consider the graph between compressibility factor Z and pressure P. The correct increasing order of the ease of liquefaction of the gas shown in the graph is. Okay. Very nice question. Yeah. First of all, this line represents Z is equal to one line. That means for ideal gas, right? And below this line, which forces are dominating? Attractive forces are dominating. Above this line, which forces are dominating in gas? Repulsive forces are dominating, if you remember. Yes. So can I say if attractive forces are dominating in carbon dioxide, right here, can I say carbon dioxide can be easily liquefied among all, right? We need to see the trend for ease of liquefaction right here, okay? So carbon dioxide will be easily liquefied. Carbon dioxide will be easily liquefied because in carbon dioxide molecules, there are already attractive forces because its curve comes below this Z is equal to one line which represents the attractive forces are dominating in it, yeah? So carbon dioxide will be easily liquefied, correct? So either this will be the option or this will be the option. Now. Let's get to know among these three. What is happening right here. I'll draw one line right here. I'll get the corresponding values of Z. right? Can I say Z for CH4 is less than Z for HN2, which is less than Z of H2? Yes. People, do you remember? I have told you in the states of matter as well. I've talked in detail in the states of matter that more the value of Z, more the repulsive forces between the gases, less the value of Z, more the attractive forces. Yes. Can I say this CH4 is having less value of Z among all? Among all, it is having less value of Z. If it has less value of Z, then force of attraction in this will be more. If force of attraction in this will be more, that means this CH4 can be easily liquefied among these three. Yeah. So first carbon dioxide, then CH4, then N2, then H2. So option A is going to be the correct one among all. Yes. Yes, absolutely, guys. All of you are right. Absolutely. Thank you, Nitish. Thank you so much, bro. Thank you. Okay, let's move on and let's get to know a few more questions right here. The density of a certain gaseous oxide. Okay, the density of a certain gaseous oxide at 1.5 atm and 20 degrees centigrade is same as that of O2 gas at 10 degrees centigrade and 4.5 atm. What will be the molar mass of gaseous oxide? So it's mentioned in the question that density of gaseous oxide is equal to density of O2. Yes. People, do you remember the density form of ideal gas equation that used to be equal to PM is equal to dRT? Can I eliminate D right here? D will be simply equal to PM divided by RT. Absolutely. Now over here I'm given a density of gaseous oxide. Can I say that is going to be pressure of gaseous oxide multiplied by molar mass of gaseous oxide divided by R multiplied by temperature of gaseous oxide? This should be equal. Density of O2, guys, it's going to be pressure of O2 multiplied by molar mass of O2 divided by R multiplied by temperature of O2. Yes, R and R got cancelled. I need to calculate molar mass of gaseous oxide. Can I simply say molar mass of gaseous oxide must be equal to pressure of O2 multiplied by molar mass of O2 divided by what? Divided by temperature of O2 multiplied by pressure of gaseous oxide right here. Now people, what is the pressure of O2 given to us? Pressure of O2 given to us is 4.5. Yes, it is 4.5 atm. What is the molar mass of O2? As you all must be knowing, 32 grams per mole divided by what is the temperature of O2 given to us? That is 10 degrees centigrade. 10 degrees centigrade means 283 Kelvin. Yes. What is the pressure of gaseous oxide? Pressure of gaseous oxide is 1.5. Yes. Just people solve it. Let me know the value. The value will be, I guess, 99.39 grams per mole. Yes. Very, very, very simple question this was, and this is how we solve this question, and the answer is going to be around 99.39 grams per mole. Absolutely, we got the molar mass of gaseous oxide. The question is done and dusted right here. Yes. Okay, let's move on to one more, guys. Let's move on to one more. At what temperature in Kelvin is the RMS speed of hydrogen molecules same as that of RMS speed of oxygen molecules at 1327 degrees centigrade? Yeah, very simple question. Yes, right? Understand, guys. Understand properly what I'll do right here. What is mentioned in the question? The RMS speed of what? RMS speed of H2 must be equal to the RMS speed of what? It must be equal to RMS speed of O2. People, do you remember the formula for RMS? RMS speed used to be equal to under root of 3R temperature of H2 divided by molar mass of H2. This should be equal to under root of 3R multiplied by temperature of O2 divided by molar mass of O2, right? Root and root got cancelled, 3R got cancelled. So temperature of H2 divided by molar mass of H2, it must be equal to temperature of O2 divided by molar mass of O2, right? We are supposed to calculate the temperature. At what temperature the RMS speed of hydrogen? We are supposed to calculate the temperature of H2. So temperature of H2 right here is going to be temperature of O2 multiplied by molar mass of H2 divided by what? Divided by molar mass of O2 right here. Yes. Now people, temperature of O2 is given to me 1327 degrees centigrade, right? You can convert it into Kelvin. So this thing is given to me. Molar mass of H2, all of you must be knowing, that is 2 grams. Molar mass of O2, all of you must be knowing, that is 32 grams right here. Yes. So people, you can get the value of temperature in Kelvin right here. So it's going to be, let me show you exactly. It's going to be 100 Kelvin over here. It's going to be 100 Kelvin over here. Yes. So you are getting the temperature of H2 right here as 100 Kelvin, right? Very, very simple question it was. Okay. Yes. Exactly, Sovojit. You're right. You're absolutely right. I'm moving on to one more, guys. I'm moving on to one more. See, what I need to identify right here, I need to check which one is the correct one among all. Okay, I'm good with the distribution curve. If you remember, we have talked about this distribution curve in detail in states of matter. If you remember, I'm given 3 points right here. Point A is this one, this is point B, this is point C, right? And we know this point represents the maximum fraction of molecules and the speed possessed by maximum fraction of molecules. That's what we call as most probable speed. Yes, this is what we call as most probable speed. Now people, if you remember, for a particular gas kept at a fixed temperature, RMS speed for the gas is maximum followed by average followed by most probable. Yes, RAM, correct? Do you remember that? Do you remember that? Absolutely. Yes, absolutely, guys. Vrms is greater than V average is greater than Vmp for a particular gas kept at a fixed temperature. Yes. So people, V most probable is the least. So A should be the most probable. This should be what? Your point B. This should be what? This should be average. This should be average, VAV. And this C should be, this should be V what? This should be Vrms. Correct? Now people, now you can select the options. A is your Vmp. Yes. B is your V average and C is your V RMS, right? This is the correct one among all. This is the correct one among all. Yes? Right? Right? Very, very, very simple question this was. Correct? Okay, let's move on, guys. Let's move on to one more question which I'll be giving to you. Okay. Now there are few questions which I've taken from the redox reaction at the same time. So let's try to do the most expected JEE questions from the redox at the same time. Yeah, let's try to do these as well. See guys what I'll be doing. See what I'll be doing. Understand properly what I'll be doing. 5 moles of this is ferric oxalate in which iron is in +3 oxygen state and carbon is in +3 oxygen state. Yes. 5 moles of ferric oxalate. I'm given with ferric oxalate Fe2C2O4. C2O4 whole thrice. Okay. 5 moles of ferric oxalate is oxidized by X moles of K2Cr2O7, right? K2Cr2O7. Correct? In acidic medium. In acidic medium. Correct? In acidic medium. What will be the value of X? People, if you remember, K2Cr2O7, it is a strong oxidizing agent. It converts the oxalate ion into carbon dioxide, if you remember. Yes. And at the same time, in acidic medium, it gets converted to Cr+3. And with this, you'll be writing few water molecules as well. This will be the reaction right here. Correct? This is going to be the reaction right here. Now, guys, what I'll be using, I'll be doing the equivalent concept. I'll be using the equivalent concept. Can I say, as per law of chemical equivalence, gram equivalence of this ferric oxalate, which I'm representing by 1, it must be equal to gram equivalence of K2Cr2O7. Yes. Gram equivalence of 1. Gram equivalence of 1. That is going to be equal to number of moles of 1 multiplied by n factor of 1 is equal to gram equivalence of this 2 will be equal to number of moles of 2 multiplied by n factor of 2. Correct? Number of moles of ferric oxalate is given to me as 5 multiplied by. What is the n factor of ferric oxalate right here? Oxygen state right here is +3 and it's going to +4 oxygen state. So what is change in oxygen state? Final minus initial value will be 1. 1 is the change in the oxidation state for 1 atom of carbon, but I have 6 atoms. So n factor of that is going to be 6. N factor of this substance is going to be 6, will be equal. N2 we are supposed to calculate. What about the n factor of K2Cr2O7? Over here, the oxygen state of chromium is +6. It is going from +6 to +3. So change is final minus initial, that is 3. 3 is the change in the oxidation state for 1 chromium, but I have 2 chromium, so 3 2s are 6. So this is something like this, yeah? Yes. So I got n factor of 2 as well, which is 6. So this 6 got cancelled. So n2 value I got as 5. What is n2? n2 are the number of moles of K2Cr2O7, which we are supposed to calculate. So we got the value of X as 5 right here. Yes. Yes. Very, very, very simple question this was. Okay. Absolutely. Let me move on to one more question, guys. Let me move on to one more question. Which one of the following is the redox reaction? Look at the question, guys. Oh, look at the question. Just look at its solution directly, guys. It's not the question to solve. Okay. See, if I consider the last reaction, in the last reaction, have a look. Zinc is having the oxygen state 0. Right here, +2. What happened to this reaction? Okay, this is oxidation and reduction. Okay. It's given separately, right? See guys, the oxidation state of zinc right here is 0. The oxidation state of Ag right here is +1. The oxidation state of Ag right here is 0. The oxidation state of zinc right here is +2. So oxidation state of zinc is increasing, whereas oxidation state of silver is decreasing. Correct? So people, this is example of the redox reaction, yeah? Because right here, zinc is undergoing oxidation, silver is undergoing reduction, yeah? So this is the example of redox reaction which we are supposed to check, correct? Right? So it was a very simple question, guys. Okay, which of the following the disproportionation? Array, yaar. Last option is the disproportionate reaction, right? Have a look. +1 to +2 at the same time, +1 to 0. Oxidation state of copper is increasing as well as decreasing simultaneously. So this CuBr right here is undergoing disproportionation, yes. And in any reaction, if the reactant will be undergoing disproportionation, that reaction is what we call as disproportionation reaction. I hope you know that, you remember that, correct? Let's try to do one question, guys. This will be the last question of the today's session. This is going to be the last question of the today's session, yes. How many moles of KMnO4? How many moles of KMnO4 will be required to react completely with 1 mole of potassium oxalate? 1 mole of potassium oxalate, right? In which medium? The reaction is going to take place in acidic medium. And as you all must be knowing, KMnO4 in acidic medium, it converts oxalate ion to carbon dioxide and itself gets converted to Mn di positive, and with this you'll write water as well. This will be the reaction that will be happening right here, right? Let's call this as 1, let's call this as 2. So can I say gram equivalence of 1 must be equal to gram equivalence of 2 right here as per law of chemical equivalence? Yes. Now guys, gram equivalence of 1, that's going to be number of moles of 1 multiplied by n factor of 1. This should be equal gram equivalence of 2, number of moles of 2 multiplied by n factor of 2 right here. Yes. What all things I'm supposed to calculate? I'm supposed to calculate the moles of KMnO4, which I'm representing by N1. N1 I'm supposed to calculate n factor of 1. N factor of KMnO4 in acidic medium, all of you must be knowing that is 5. Or if you do not remember, oxidation state of Mn right here is +7, right here is +2. Change, final +2 minus initial +7. The change is going to come as 5. 5 will be the N factor, yeah? This will be equal to N2 value, number of moles of potassium oxalate, that's given as 1. And what is the N factor of potassium oxalate right here? Over here the oxidation state of carbon is +3, over here +4. +3 to +4, change in oxidation state is 1. 1 is the change for 1 atom, but I have 2 atoms of carbon, so N factor is going to be 2. So N1 value right here will be 2 divided by 5, that means 0.4. So 0.4 is the value of N1, and what was N1? N1 were the moles of KMnO4 right here, which I was supposed to calculate, yes? So people, with this, I'll be taking a leave right here, and there are few questions which will be your homework. This question, just take the screenshot of it. I want you guys to do it and let me know the answer in the chat box. This one, correct? Just give me a second, just give me a second, just give me a second. Just a second, guys. Okay. All right, so one important thing right here for you, that is the JEE and CBSE 21 crash course, right? JEE and CBSE 2021 crash course, which we are starting on the actual Vedantu platform. People, do get enrolled in this if you want to actually boost your rank, okay? If you actually want to boost your rank in JEE 2021 as well as CBSE 2021, what you guys are going to do, get enrolled in this one. It's going to be highly beneficial for you, okay? People, and over here you are getting 20% discount as well, and at the same time you have got actually the limited time, and in this limited time is going to decide your entire career, trust me on that, okay? So do get enrolled in this if you want to shoot up your rank in your JEE as well as CBSE, right? So how to get enrolled in this one? Let me tell you, there's a link in the description box of the video. I want you guys to click on that link. Use the coupon code as WSCC21. On using this coupon code of WSCC21, you guys are going to get 20% off again right here. And after 20% off, you guys are just getting it for 9600. That's it. Yes. So do get enrolled in this. That's my personal suggestion. Okay. So let's catch up there. Let's catch up there in the crash course batch. Yeah. So people, there is one more link in the description box of the video, that is for the Telegram, right? Do click on that link as well, get added to the Telegram link, and get added to the Telegram group, and stay updated about the classes at the same time, okay? And people, at the end, for the ones who have not liked the video yet, do like the video, share and subscribe the channel at the same time, so that everyone gets benefited out of these sessions. So people, this was all from my side in the today's session. I'll see you guys again tomorrow at 5:30 with Chemical Kinetics Part 2. See you tomorrow at 5:30. Till then, you guys take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye-bye.